Assalamu alaikum everyone. I hope everyone will be fine. Thanks to organizing committee of International Conference on Applied Zoology. My name is Mehran Khan and I am a MPhil candidate at Department of Zoology, Abdul Khan University, Mehran. Today my poster presentation topic is hepatozoon spillover from wild to domestic animals through ticks. Moving toward its abstract. Different ticks were collected from domestic animals, and those ticks were subjected to morphological analysis as well as DNA extraction. The extracted DNA samples were then subjected to PCR to amplify 18S RNA fragments of hepatozoon species. In morphological results, we identified a total of 12 tick species. In molecular results, we identified 3 hepatozoon species in our ticks which were collected on domestic animals. An overall infection rate of 9.3% was recorded. In phylogenetic analysis, our 3 hepatozoon species were clustered with their counterparts from different countries. We identified different risk factors in which 3 risk factors were significantly associated with potential spillover of hepatozoon from wild to domestic animals. Those 3 factors were free-ranging animals consuming those animals which were consuming food from wildlife habitat, and those animals which were living inside wildlife habitat or near to wildlife habitat. Our study is the first study on hepatozoon canis detection and Rhipicephalus sanguineus in Pakistan. Part of this, our study for the first time detected hepatozoon iorubor and Rhipicephalus hypsilidus ticks and hepatozoon colibri and Hemipacillus sulcata and Hilum anatoricum ticks. Our study suggests a potential spillover of hepatozoon from wild animals to domestic animals through ticks. Moving toward its introduction. So, hepatozoon are apicomplex and parasite, and there are more than 300 species in this genus. They are considered to infect all terrestrial vertebrates, including wild animals as well as domestic animals. They are transmitted by arthropods, and mainly they are considered to be transmitted by ticks. They are globally distributed, and some of their species are more prevalent in specific host. For example, hepatozoon iorubor is very prevalent in snakes and wild rodents. Hepatozoon colibri is commonly found in snakes, whereas hepatozoon canis is very common in canids. And there is always a possibility of crossover to unnatural host via ticks. And when hepatozoon jump from their natural host to unnatural host, so it has been studied that they show high pathogenicity in those unnatural hosts. Moving toward its methodology, so the figure 1 shows the study area. The study was conducted in Khyber Pakhtunkhwa, and it was mainly restricted to 3 districts: District Bajawal, District Mumand, District Malakand, and District Lucky Marwat. The figure 2 show the schematic diagram of methodology. First of all, ticks were collected, then those ticks were subjected to morphological analysis, and after morphological analysis, the ticks were preserved. Subsequently, the ticks were subjected to DNA extraction. Then PCR was performed for those extracted samples, and the amplified PCR amplicons were sent for sequencing. When we received the sequencing, so we subjected those sequencing to blast analysis, and subsequently phylogenetic analysis was conducted for those sequences. So both the molecular and the morphological data was subjected to statistical analysis as well. The table 1 show primary tails. 18S RNA the sequencer, which is here in the column, under the sequence column, was used to amplify 18S RNA fragments of hepatozoan species. Moving toward its result, so table 2 show the detail about the collected ticks. Here are the detail of all 12 tick species which were collected in this study, as well as morphological identified. Hemibacillus carnopantata, Hemibacillus bispinosa, Hemibacillus kashmirensis, Hemibacillus montgomery, Hemibacillus sulcata, Hilum anatolicum, Hilum oscupensi, Hilum isasi, Ribosipilus hemisalidus, Ribosipilus microplus, Ribosipilus sanguinis, and finally Ribosipilus teoreticus. Table 3 show the details about the hepatozoan species which were detected in ticks in this study. Hepatozoan colibri was detected in Hilum anatolicum ticks which were collected on cows. Hepatozoan colibri was detected in Hemibacillus sulcata ticks which were collected on sheep. Hepatozoan aerorbur was detected in Ribosipilus hemisalidus from goats, and Hepatozoan canis was detected in Ribosipilus sanguinis from dogs. The table 4 show risk factor associated with hepatozoan spillover, and there were 3 factors which were strongly and significantly associated with the potential spillover of hepatozoan from wild to domestic animals. Farming type, the free-ranging domestic animals were at higher risk for potential hepatozoan spillover. Similarly, among food supply, those animals who are obtaining their food from the wildlife habitat were at higher risk. Among the farm building location, those domestic animals which were living inside wildlife zone or near wildlife zone were at higher risk compared to those who were living inside villages. This is and the result, this is the phylogenetic tree, and this phylogenetic tree, the sequences with the black dots are sequences of our study. Here the hepatozoan canis was clustered with the same species from Israel, from Romania, from Zambia and Iran. Similarly, the hepatozoan colibri was clustered with same species from Iran, and finally the hepatozoan aerorbur was clustered with corresponding species from Portugal, from Croatia and Ghana. So now moving toward its conclusion. Our study confirmed that hepatozoan canis is commonly found in Ribosipilus sanguinis. Our study for the first time worldwide detected hepatozoan aerorbur in Ribosipilus hemisalidus and hepatozoan colibri and Hemibacillus sulcata and Hilum anatolicum. In our study, we found that 3 risk factors are significantly associated with the potential spillover of hepatozoan from wild to domestic animals, and those 3 factors were free-ranging and wildlife habitat, receiving food supply from wildlife habitat, and the location of farm building inside wildlife habitat. Moving toward its acknowledgement, so I am thankful to my supervisor Dr. Abid Ali and as well as to the Pakistan Science Foundation for their support. Thank you for listening me, and thanks to organizing committee for providing me such a platform.